Good evening, everyone. On the behalf of Department of Mathematics, Wilson College Autonomous Mumbai, I welcome you all in the today's session. Our today's guest is Mandar Khasnis sir. He is an associate professor at Department of Mathematics, Srimati CHM College, Ulhasnagar. He will deal with the topic of functions of one variable today. Over to you, sir.
Yeah, thanks. Thank you so much. So let me share my screen. I have already shared the link by which you can download the problem sheet. I hope everybody could do that, those who have joined. If anyone is not able to see the link, I can post it again. Everyone got it? Fine.
Yes, sir.
Yeah, I assume. And I move to the problem discussion. So you can pick up any one problem and go ahead. Just to begin with the first one first, let's start with the first question for that matter. I think I have to close my video. It's lagging. So excuse me for this. I'm closing my video. Yeah, I hope you can hear me. And the same sheet is being downloaded by you. Just please check. I hope I have shared the same link. Still, just to cross check. Yeah. So, can you see the first problem? Same problem that is on the screen here. Yes. Hello.
Yes,
Or
Yes,
is
sir.
sir.
it? Fine. Okay. So let's quickly rush through this. This is simple. Can you handle it? I'll take 2 minutes. Pause. Try it out. Don't disclose the answer. If you are done, just put a thumb or something. Okay. Can someone tell me the steps? If you have not got the answer, is fine. I want to know how to proceed in such cases.
So
Oh,
we can evaluate
uh,
f of x by I first and then multiply it by I square.
okay. So you mean you put the in place of x, you put x by I and try to see what the expression is.
Hmm.
Okay. Fine, but that will be too time consuming. You don't have that much time actually. So there must be some other way out. Hmm.
So it can be 0 by 0 form,
Yeah, actually, yes, you can do
maybe.
that. You can do that. What Sunil said. Yeah, someone else was talking. I missed it. Please say. Sorry. Somebody said 0 by 0. I missed that point. Who was talking?
Yes, sir. I'm.
Akash. Yeah, tell me.
Sir, if you substitute f of x and if you up x tending to 0, then 1 by x, and in upper side there is summation of f of x. Then you substitute 0, then 0 by 0 maybe. Then you
Okay.
differentiate elevator rule.
Mm-hmm. Okay, so one approach is that. Yeah, I mean, but then L'Hopital, then you have to look for the derivatives, and it will again be little lengthy. One option is, yeah, you can of course try. All of you can try at your own way. One thing is, yes, what Sunil said is also okay. Like you put x by I, try to simplify, and then multiply by I square, and then see divide by x. Take the limit inside. See what happens. You can do that. Okay. Only my point is, if I change my function a bit, see, this approach is function dependent. If you change the function, things will, means my point is, this is very interesting limit. That is something I want to say. But yes, Sunil's idea also will work, and you are going to get the answer fast. Okay, if you go by that, I'm just showing. So one path I'm not taking, but everybody knows. You try it out and get the answer. Okay, so that I'm not saying. So what I'm just saying Sunil's idea. Sunil has suggested what it is. You actually evaluate f of x by I. Put the value. So 2 times x by I minus sine x by I. Now multiply by I square. So if you do that, it will be like 2I square times this whole thing. So this will be like 2xi minus I square sine x by I. Now this is ith term. You can divide by x. Take the limit. Now x will go. Take the limit x goes to 0. Now that won't be, I mean, that won't affect this. It will be just 2i. And this is like I can take one I down. After taking limit, that will be 1. So it is like 2i minus I. And you have got it as I. And then it is summation 1 to k. So it's simply kk minus 1. I mean kk plus 1. That is 45. So you get it as k equal to fine. I'm not going. Okay. So this is one path which is correct. I just want to show you another which may help in some other problem. This problem is over. Is it over for everybody? You can ask if you are not comfortable with what I said. Can you manage after this or no? Why can't
Oh,
you are
yes, sir,
not
we can
getting
manage.
things? Thank you, Arib. So another thing is, it's you see when you see such a expression in, I mean, one hint is we try to go by definition. All right, because if I expand this, if I actually try to write it in expanded form, what do I get? I equal to 1. So it is f of x minus, sorry, plus I equal to 2. So 2 square f of x by 2, 3 square. I'm just writing it. You don't need it, but I'm just writing for understanding. That's it. And I have last term as k square f of x upon k. Okay. Now we already know the function, so we know it's differentiable at every x. Now, in particular, since here I have x tending to 0, it is something like limit h goes to 0 kind of a scenario, or x goes to 0 is fine. fx minus f0 I would like to then bring in. But why? What is f of 0? That is 0 anyways. So what I will do is I'll try to adjust here. So I will say fx minus f0. Now this upon x is available. I'll take it down. X minus 0. So I'm writing x plus 2 square f of x by 2 minus again f of 0. I want to write here x by 2. But if I want to write x by 2 here, 1 power of 2 will go away. So I will have just 2 times this whole thing. Plus, now I hope it's clear what I'm doing. F of x by 3 minus f of 0 upon x by 3. K, okay? F of x upon k minus f of 0 upon x by k. And now you know when we take limit, what do we get? So just now if I take limit x goes to 0 of this whole thing, what am I going to get? Is this is f dash 0, 2 times f dash 0, 3 times f dash 0. So it is like 1 plus 2 plus 3, so on up to k into f dash 0. And now how much is f dash 0? F dash x is 2 minus cos x. So f dash 0 is 2 minus 1. That's 1. So you get this is equal to 45. So k plus 1 is k plus 1 by 2. Sorry, 1 by 2 is equal to 45. So this tells me k equal to how much?
So 9 and minus 10.
Why minus 10?
So
Ah,
9.
okay, means minus
9
10
comma
means
minus 10
correct. Yeah, out of which minus 10
is
won't
with the
work
opposite.
because it's not a natural number. So 9 is the answer. Is
Hmm.
everyone okay? That's it. So only thing is, see, of course, this is perfectly fine in our case. Only why I'm showing this is sometimes this technique might be more faster than actual substituting and simplifying it. So one should know both the techniques. So I'm just showing this. That's it. Okay, let's move ahead. I think we have less time and many examples. So second, I'm skipping because it is similar. You see that? And a hint is f dash 3 is given. That's a hint. That means somewhere we wish to, bring in f dash 3. All right. That means f of x minus f of 3 upon x minus 3 can be brought in for the discussion. I mean, in the expression. So you try to express this in terms of expression involves f, which involves f dash 3. Something like f of 3 plus h minus f of 3 upon h, limit h goes to 0. You got it? Where h is something like 1 by n. Okay. So I'm not doing it. Please try. So this is for you to work it out. Try on similar lines as one. All right. Let's move ahead to third question. Let me take it on the new page. See, I'm discussing few. Some questions I won't be even discussing due to time constraint. Yeah. 5 from R to R be a differentiable function. Phi dash is increasing. Yes, come on. This is any answer. This is easy. Okay, look at this. What do you mean by phi dash is increasing? So can I write phi dash x is going to be greater than phi dash 1 for that matter? It's throughout increasing strictly. So for all x bigger than 1. Fine. That means, but then phi dash 1 is 0. So phi dash x is bigger than 0 for all x bigger than 1. So after 1, phi dash is positive. But derivative is positive. What can you say about then phi? Huh? Increasing, decreasing. What can you say?
It's strictly increasing.
Correct. Is strictly increasing on 1 to infinity, means 1 onwards, basically. But that means in particular over this closed interval 2 to 3, it's an increasing, strictly increasing function. So where will it have its minimum and where will it have its maximum?
At
Minimum will,
2, it
correct,
will have minimum,
correct.
and at
So
3, it will
correct.
have maximum.
That means alpha is, actually speaking, to be very clear, alpha is phi of 2 and beta is phi of 3. Now whichever is the option, yeah, this is the option.
Option A.
Okay, simple. All right, I'm just moving ahead. Mm, yeah, this you can try actually. I'm not getting into it. X root mod x, you see how the graph looks first of all, uh, and then try it out. I'm not disclosing the answer. This I'm putting on you. Okay. Fifth one, can somebody? Now, fifth onwards, you can expect what you are going to use. See, such question is expected. So it's based on what?
The mean value theorem.
Yes. So is A true? See, this interval suggests what you should try at least.
So can you give a few minutes?
Yeah,
To
okay, okay. I'll wait for one more minute.
so first one is wrong. The
Yes, first is
it will
wrong.
be one actually.
Correct. First is wrong because in fact, if you apply it to 0 to 2, it is like f2 minus f0, that is 2 minus 1, 1 upon 2 minus 0, 1 by 2. So there will be some c such that f dash c is half. That is guaranteed by LMBT. So this is not true.
So option B is correct.
Mhm. Right. Because if you apply mean value theorem to these two intervals, what you are going to get? LMVT, if you apply to these two, you are going to get something like 2 minus 1. So you get x2 such that f dash x2 is f2
F2 minus F0 by 2 minus 0.
by 2 minus 0, but that is half.
Half.
And you also get f of x, f dash x3 between 2 and 4, such that this is f4 minus f2 upon 4 minus 2. 4 minus 2, yeah. So that is again
F3
half,
minus 2 by 2, half.
right? So that means there are 2 points, x2 and x3, such that these two are equal, in other words. So this is a correct choice. Now, if it is not multiple correct, then you know that C and D will be false. But I mean, if it is multiple correct, mm, then you can check where what happens to C or D. But from here, it should give you a hint. Mm,
So it wouldn't be because
mm,
in f of x2,
mm,
uh, so we the interval is 0 to 2, and it says that the
mm,
function is equal between the interval 0 to 2 and the interval between 2 to 4. So
mm.
it can't be strictly increasing.
Correct. On the other side, I mean, yes, that is a good guess. In fact, to be very precise, what I can do is I can apply Rolle's theorem. Rolle's theorem to f dash on x2 to x3. If I apply, what do I get? There is some x4 such that f dash the derivative of f dash, that is f double dash at x4 is 0 by Rolle's theorem. But that means this cannot happen. Strict greater or strictly less for all x won't happen because then in between it's going to be 0. Okay, or whatever Sunil said is also a correct argument to go ahead with. Good. So I think I should move to next. Yeah, this is again, you think I'm not getting into sixth, kind of similar work. So maybe seventh, I can. Seventh seems easy.
Sir, can answer be D?
Okay. Mhm. So you require A3 to be 0. Even 0 is fine because mod x is troubling. Mm,
I think it
mhm.
A3 and
Means a simple question. The question
plus
actually.
A2.
Ah, sorry, I couldn't hear you. Yeah, Akash.
So if both A1 and A3 equal to 0, then we get a simple equation A0 plus A2.
That is
True,
correct.
sir?
See, if A1 and A3 are 0, yes, yes, you are correct. If A1 and A3 are 0, then a function is differentiable is fine. But how about reverse? Because we are saying only if. So is it like if A3 is non-zero, function won't be differentiable? That also we have to take care. Yeah, you got my point.
Yes, sir.
Fine.
Sir, option B will be incorrect, I guess.
Option B.
Yes, sir. Sir, if we use the definition of mod x,
Hmm.
so there will be two cases. First cases when mod x is negative.
Hmm.
So in that cases, we are getting first we assume in positive cases. So in that case, we are getting all the terms are positive, and then when we
Hmm.
differentiate, so we are left with only a1,
Hmm.
which can be positive or negative both.
Hmm.
But when we assume function is negative,
Hmm.
because function is mod, so we are
Hmm.
left with minus of a1. So
Hmm.
we are getting a1 is equal to minus of a1. So
No, no, but x is there. No, means it's not just minus a. You will get it as minus a1 x.
yes, sir,
Mm,
but
yes, sir.
after differentiating, we are getting uh, if a function is differentiable, then left hand derivative and right hand derivative must be equal.
So you get a1 and minus a1, correct?
Yes, sir. So that can't be equal.
That means a1 should be equal to minus a1, but that will
Yes, sir.
force a1 to be
Zero.
0,
Yes, sir.
correct?
Then only it is
And that's the
possible.
point. That's the point. So actually,
Then
this is true. Huh,
C is true then.
correct. C is true. Understand the point that, see, this is anyways a very, non-troubling element because this is mod x square is just x square. So mod x square is nothing but simply x square. Okay, and we know it is everywhere differentiable. Mod x cube can be written as x square into mod x. I have some lag, I suppose. I don't know why. So x square into mod x, right? And x square mod x is everywhere differentiable.
Yes, sir.
So that means the only fellow who will create a problem is this. So we have to get rid of this at x equal to 0 and only this. So that means you have to make a1 0
Hello,
basically.
sir.
Yes,
Yes, sir. This is the option C only true because we are
correct,
asking only if. Okay.
correct.
If we put a1 mod x and a3 mod x's cube, then
Hmm.
if we take common the term mod x1
Uh,
and mod x into a1 plus a3 x
x,
square.
x
And
square,
a3
correct.
x square is defensible, I think,
Yes,
and x square into mod x also defensible. That is why just
right,
only this term is
right.
creating problem.
Correct. So only this term. Correct. Good. So I hope that point is clear. Okay. Let's move to, yeah, now 8 I have just written. Uh, if time permits, we'll come back, but it's again Taylor series kind of a point. So I'm right now making a move to next question because there are some more which I am intended to discuss. So okay, let's look at 12th question. I'm little keen to deal with. So let's look at 12th right now. Now, this is easy to guess, but I need reason also. Any answer?
Sir, here AP is continuous and endpoint 0 and 1.
Yes. No, no, that is not given. That's a tricky
Mm,
question. In fact, function is available only on open 01.
yeah.
Hmm. Yes, that's the point. In fact,
Here function is it is given that function is differentiable in 0 1 always.
open. Yeah.
Open 0 1 and open
Mhm.
in open 0 1 it is continuous also.
Correct.
And if we get endpoint, then I can, because this function is continuous also in this 0 1,
Hmm.
uniformly continuous. So
Hmm. Okay. Right. You're correct.
uh,
So we can check whether AN is a Cauchy sequence or not. Then we
Correct.
can find out whether it
That's
is convergent or not.
that is the point. Exactly, Hari. You got it. Is it clear? So I'll join two statements made by two different uh, students. Supratim said that F is uniformly continuous, and Reep said that we try to show F of. I mean, we try to show that AN is Cauchy sequence. AN is a Cauchy sequence. Okay. Now, are we going to get these two? By the way, uniform continuity, is everyone aware how to prove? Do you know this statement? If function is differentiable with bounded derivative, then it's uniformly continuous. How do you prove it?
yes, sir. It is by going to the definition of using the LMVT in
Using mean
between.
value theorem, right?
Yeah.
So if I'm not even getting into uniform continuity, let's not get into it. If I want to show n is Cauchy sequence, how do I
Mhm.
show it? I'll work with this difference, an minus am. I'm not writing precise argument, but this is the idea. So what I can do is, it is f of 1 by n minus f of 1 by m. Okay. So I assume n is bigger than m for time being. Okay. Then if I have this f of 1 by n minus f of 1 by m, see, n is bigger than m, so 1 by n is smaller than 1 by m. And over the interval 1 by n to 1 by m,
Use LMVT.
function is use LMVT. So you get this difference is equal to mod f dash at some number c between these two times mod 1 by n minus 1 by m. And now this is bounded by 1. So this is less than 1. So this is less than mod 1 by n minus 1 by m. Now we already know that this sequence 1 by n sequence
Is
is a
Cauchy.
Cauchy sequence. So this can be made less than epsilon for all n bigger than m bigger or equal to n naught. There is no issue. And hence this will happen. I mean, this will be controlled, and hence you get an Cauchy sequence. Understand? So and then now we have R to be complete. See, the codomain is R. We are not, this is a domain. But when I look at an, f of 1 by n, it's uh, it's real numbers codomain, and hence it's a complete, means every Cauchy sequence is convergent, and so you
Yeah.
get an to be convergent. Okay, that's the point. So there is hidden LMVT which is playing some role here.
Yes.
Yeah.
Good one. Good question.
Right. Thank you. Okay. Right. Mm,
Sir, otherwise,
huh, huh.
it is if we assume if we
Hmm.
if it is uniform continuous, then uniform continuous is a function, I think, carries Cauchy sequence to Cauchy sequence
Correct.
in some, there are some condition in endpoint or something like that.
But if no, I mean, if the function is uniformly continuous on some domain,
Yes.
then it will map Cauchy sequence to a Cauchy
Into Cauchy
sequence
sequence.
in that domain. Means if you have a sequence Cauchy in the domain, then f of n will be Cauchy in the range, basically.
Yes.
Yes. Proof goes in this ways on this way only. Good. Okay, I'm just going ahead. I do not want to look at Taylor's right now. Even see, these are all Taylor's. Even this is Taylor's. I'm just giving you a hint. It's simple. You apply Taylor's theorem and see. Some extra questions I had just put, I mean, which are out of my uh, this thing, but okay. So I have 16th question to discuss. This one.
Hello, sir.
Yeah, yes.
So all of these questions are from GMPYQ or some other sources?
Most of the questions are from that. Some I have means couple of questions I have just constructed. Means whenever I means I just thought, and then some or the other time I have constructed some questions. But most of the questions are from the jam previous jam papers. Uh, Maybe couple of questions you will find from Madhava competition. You know Madhava math competition.
Yeah,
Yes,
yeah.
sir, for undergraduate level,
Correct,
all
correct.
for mathematics Olympiad.
Right, right. So from that also I have picked up some questions. But this is typical. This is typical jam.
So first one is wrong by
Okay, let
LMBD.
me let me see. I have not. Yeah, 4 minus 0
We
upon
will get
2
less
minus.
than.
Yes, this is wrong because so I'll just write quick points. So over 0 to 2, if I apply LMBT, you get some f dash c is equal to 4 minus 0 upon 2 minus 0, that is 2. So this is not possible. There is a point, in fact, where f dash is greater than 1. Then let's look at B. Yeah, in fact, B is true. Just now we got it. We got 1x1.
Yes, sir.
So
So
C
B
is
at least
true
is
also.
true. Okay, C, let's see. 12 minus 4. So over 4 to 8, what will happen is f dash of I'll write x2 is 12 minus 4 is 8, and 8 minus 4 is 4. So again 2. Yeah, so this is also true. And D, oh, this is similar to what we worked with. Is D true? No, you're taking more time. See, this should tell you immediately.
Sir, can you tell by Rolle's theorem? If
Ah, because this is f dash x1, which is 2. So f dash x1 is equal to f dash x2. So I can apply Rolle's theorem to f dash. And that means f
Yes,
double dash
D,
has to vanish. Huh.
D is true by
D
Rolle's
is true.
theorem.
Correct. Yeah. So B, C, D all are true. Hmm. Good. So this was easy. I want to move to, yeah. I I want one more question to, I don't know whether it is, I forgot to include or, okay, let's look at one of 17 or 18. Say 18. Let's look at 18. You can see these are all mean value, and these are purely from jam, means all.
So similarly, here we can use the Rolle's theorem. Sorry,
Correct.
LMVT.
LMVT. Correct.
Yes.
So try it out. Uh,
First one is wrong.
First one is wrong is 0 to 1.
So
So correct,
we are
because there
getting less than,
is, correct. You are getting f dash equal to minus 6.
yes, sir. So mode will be less than 6.
Yes, less.
Correct. So this is not true. This is true
So
then.
B.
Same pattern.
Yes.
F dash x2 equal to 0. Mm, in 0 to 3.
So C is true by intermediate value theorem.
Hmm. Okay, that's a nice idea. So what happens is between 1 to 0 to 1, if I apply.
0 to 1 and 1 to 2, there are a change of sign one,
Yes, sir. It
and
is
Correct.
changing sign from positive to negative. So there
Positive.
must be a point
Correct.
where it will be
So
equal to 0.
correct. 1 to 2, then you have 10 by 1. It's just 10. So this is negative, this is positive. So this must be true. Okay, because f dash is continuous because it is differentiable. See, in general, f dash need not be continuous, by the way. Okay. So I have
sir,
a
if dash,
question. Huh.
sir, if
Yeah.
dash need not be continuous, but here given option f double dash, that is why
Huh,
taking
huh.
f dash is
Yes, yes.
continuous.
Correct, correct. That's true.
And
So,
if for last option, we use the same thing in between the interval. Here, I think uh, minus
uh, mm,
here one is my 6, and yeah, and using the LMBT in the interval, f dash
uh,
on f dash
f
using the
dash.
LMBT, and 2 3,
So
yeah.
2 to 3, f dash x3 will be 2 minus 8 is minus 6. So minus 6 by 1, that is minus 6. So now you apply to, like, this is and this. So f dash x1 equal to f dash x3. So this must be true. That f double dash will vanish by Rolle's theorem. Correct. Yeah, I was asking one question which you can think of. Like, even if it is not given, not in this case. In this case, you need f double dash. But if function is just differentiable, is what given to us, can we still guarantee C must be true? Forget the option. So we have no information about f dash, continuity of f dash. Still,
Yes, it is the derived function also
hmm,
okay, follows the intermediate value property.
correct. That's the point. I just wanted to highlight that although continuity is not there, but IVP is available for the
Yes,
derivative, and that's enough for our argument. Very good. Very good. Yeah. Um, uh, I'll just look at 20. 20 is little tricky than all these typical ones. So look at 20. And I have one more problem to discuss actually. So let's see. Some I may have to extend my.
yes,
Let's.
yes, okay.
Sir, here we can use the LMVT as it is continuous on closed interval and differentiable on open interval. So in the mode f dash of x,
Correct.
there will be
Mhm.
uh,
Mhm.
so we can use the inequality in that is f dash of x will be greater than minus 3 by 2 and will be less than 3 by 2, and then we'll substitute the f dash of x and the values given, and then we
Mhm.
will take one of inequalities to get f of 1.
Okay, but how do we get f of 1? Where will you apply LMBT?
Minus 1 to 3.
Okay, so if I apply over minus 1 to 3, what do I get? Sorry, not equal to. So when we apply, what are we going to get is some f dash at some c equal to f3 minus f minus 1, that is 7 minus 1, 6, divided by
4.
3 minus 1, 4, that is 3 by 2.
Right.
Correct. So there is already somebody who is taking the value 3 by 2. F dash takes a value 3 by 2 between minus 1 and 3. Fine. Now what to do?
Sir,
Problem
if
is I want
function
f of
is
1. Ah,
sir, if function is continuous in minus 3 to 3, then it is also continuous in 1 to 3.
1 to 3, yes, correct.
Then we can apply instead of -1, if you apply in 1 f of
So let's apply to this interval. Okay. And I get some f dash at x1 is equal to something like f of 3. So I write directly 7 minus f of 1 as it is upon 3 minus 1, isn't it? So 7 minus f of 1 by 2. Now what to do? But this
sorry,
is
f dash.
again less than or equal to 3 by 2.
Yes, sir.
Some I'm just writing, I mean I don't know whether this will help. So 7 minus f of 1 is less than or equal to 3.
Then f
Right?
of 1 is less than equal to 4.
So f of 1 is bigger or equal to 4, right?
Yes, greater than equal.
Greater than or equal to. Okay, I got one information. Now what to do?
Answer again from -1 to 1.
You are left with another interval, another part of the interval. Apply it. So you get f dash x2 is f of 1 minus f of minus 1, that is 1, divided by 1 minus minus 1. So f of 1 minus 1 by 2 is again less or equal to 3 by 2. So f of 1 minus 1 is less or equal to 3. So on the other side, I know f of 1 is less or equal to 4. But this is enough to tell us what is f of 1.
4.
4.
F of 1 is 4. Okay, so this is nice idea. I hope it's clear
Yes,
to all.
yes. This is good
Mm,
one.
mm. Because we don't know actually
Yes.
F1.
Hmm.
It's interesting. Yeah. Of
Yeah.
course, there are other
I
ways.
think this time in
Uh,
Jam it will come because PPVRs here they are using LMBT several times in a question.
right,
This
right.
might also come.
Something like this may come.
Yes. Yes. That's how you have told that you will put some extra question for us on homework in the previous class. Is it from that question?
Uh, I don't actually. I'm sorry. I don't get you. Uh,
I say you told in the previous class
uh-huh,
you will left for some problem for us trying.
uh-huh.
Is this question from that collection or
No,
is
no. This is actually
okay?
from I think one of the jam. I suppose.
Yeah, yeah,
So that only. Yeah. Now I'm going to last time's problem sheet. Okay.
yeah.
And I left one question unattempted. I want to catch up that. So I'm just going back and
Okay, sir.
yeah, I want to deal with yeah, question number 10. I asked you to try it out. Has anybody? I wrote a mean value theorem as a hint. This is I'll go to library and open today's sheet only. It is better. Yeah, here on a fresh page we'll discuss. Yeah, see those who have some other commitments can I mean leave because I'm extending. So I don't mind if you are. It's fine if you are. You have something else. Okay, so we'll just discuss this and then we'll stop.
Okay, sir. No problem.
Yeah. This is again something constructed one. So forget f double dash. Can you say what is f dash at 1?
Sir, if we take the interval 1 and 1 plus n,
Mm-hmm.
1 and 1 plus 1 by n, I'm taking this interval and using LMBT.
Mm-hmm.
So simply we can differentiate on both sides and perhaps we will get some ideas. Like f
But
dash of 1 plus 1 by n and
uh-huh.
into minus 1 by uh, n square is equal to 0, and then put the
Okay.
values 1.
But right side you will say 0.
Yes, sir, after differentiating.
But the problem is now you may not, you don't know how the function is behaving at other points. See, understood.
Yes,
My thing is, we know only f of xn for some selected values xn's. So on some selected values, if it is constant, that doesn't mean it is throughout constant. So on the right side, the derivative, may not be zero, isn't it? Means it's enough, not enough information to say,
So,
huh.
as a definition of by using sequence of continuity, for n is 1 plus 1 by n, then f of n is tends to f of a. Hello.
yes, sir. He is trying to say using sequential criteria, 1 plus 1 by n is goes to 0, and 1 plus 1 by n goes to 1. Then f of the functional value also goes to f of 1.
Sir, answer will be
Oh,
0.
okay. Uh,
Sir,
huh.
sir, actually, I have constructed one counter example. F of x is equal to x minus 1 by n.
F of x equal to
X minus 1 by n.
x minus 1 by n. Okay, let's see. F of x is equal to x minus 1 by n. Okay,
And yes, sir. And then
but what is n? Fixed natural number?
n can be any number. Yes, sir. Arbitrary. So it will f of 1 plus 1 by n will always give 1.
To understand, when we write fx equal to this, n cannot vary, because then otherwise you are talking about different functions for each n. Understood my point?
Yes, sir.
So
Then it should sequence of function, I think.
this will become sequence of functions. Uh, so
So
that
we
Or
can take limit as n tends to infinity on both sides of f of 1 plus 1 by n equals to 1. Then we will get f of 1. We can
correct.
find out.
That is the first step. We can of course try to get at least f of 1 first to begin with. So so if I take my sequence xn as 1 plus 1 by n simply, then xn converges to 1, and f is continuous. It's differentiable, means it's continuous. So f of xn must converge to f of 1, right? But we know f of xn. F of xn converges to 1. It's a constant sequence 1. That means f of 1 at least. So this implies f of 1 must be 1. First observation. Continuity gives me this. Now you see f dash 1. Suppose I want to get first. Because what is f double dash 1? F double dash 1 is limit x tends to 0 of f dash x minus f dash 1 upon x minus x tends to 1. I'm sorry, x minus 1. Is it fine? But
Yes, sir.
so you first require f dash 1. So let me write f dash 1 first. But that is limit x goes to 1 fx minus f1 upon x minus 1. And now we know f of 1 is 1. So this is this is simply 1. Now how to get this? We know that it exists because function is differentiable. We know that this limit exists.
L'Hopital.
Okay, L'Hopital. But problem is we have
Because three,
uh,
No, numerator must goes to 0 actually. So f of x must goes to
so
1.
but
0 by 0,
that
0 by
goes
0
to 1. 0 by 0. But problem is you have no clue about f dash x.
but 3 times differentiable and
But
But
f dash, what do you put? Means how do
uh,
you evaluate is the problem.
sir, since limit exists,
uh,
so denominator goes to 0. That means actually it is 1 by 0, 0 tending. That is uh, infinity tending. So the numerator must goes to 0.
yeah, it goes to 0 anyways because you know f of 1 is 1
Yes, sir.
and the function is continuous. So limit fx is 1 as x goes to 1. That is known. Only problem is if you want to write further that this is f dash 1, sorry, f dash x upon 1 or something, you need to have some information about f dash x. How does it behave?
it is continuity
Ah,
of F dash.
some more information. Actually, f dash 1 can be calculated. We have enough information. We have f of xn. So, see, can I write this is equal to limit xn tends to 1? Any xn, f of xn minus 1 upon xn minus 1. Is this okay?
Yes, sir.
Because whenever limit exists, limit along every sequence also is equal to the
Yes,
main
yes,
limit.
yes, yes.
And now it's done. You know f of xn. F of xn is just 1. So your numerator is 1. I mean 1 minus 1. So this is actually 0 by something. Limit xn tends to 1. And so you are going to get it is like limit n tend to infinity of 0. Just 0. So this is going to be 0. Understand? I'm using the fact that limit is existing. So I'm making using a facility that instead of calculating the limit, I'll calculate the limit along any sequence converging to 1. So in particular, I am choosing this sequence, which I can because limit exists. Right? Now plug in this
Mm.
over here. So I want limit x goes to 1 of
Sir,
f
I have
dash.
a doubt here.
Yes, Sunil.
Sir, here we can see that xn tending to 1.
Right.
So in the denominator, it is
Uh,
1 minus 1. That is actually 1 tending minus 1, exact 1. And in
no.
the numerator,
No,
Tending,
actually,
tending, but not
tending
equal.
one, not equal. Yeah.
yeah, that's what I'm saying.
Uh,
Xn is tending to 1 and minus
correct.
exactly 1.
Correct.
And in the numerator, here we have given f of xn, and f of
As
xn is tending to f of 1.
no, f of
And
xn is 1 itself.
On itself.
F of xn is 1. I'm choosing my sequence xn as this 1 plus 1 by this sequence.
Okay, sir.
So this becomes 0 only directly because it is 1 minus 1 simply. And this is actually non-zero quantity.
Okay, got it.
Because limiting sequence 0 by xn minus 1, 0 by comma 0 by 0,
Correct. So
in
it's a
this
zero
way,
sequence.
0 sequence,
Actually.
ultimately 0.
So it's
Actually,
zero.
I was thinking it is varies from tending to one. That's why.
Fine. Good. Yeah. So now I'll try to come back to our work and try to plug in this because f dash 1 is 0. But still there is a question because how to now deal with f dash x? At least for f dash 1 we had some information about fx at least at some points. So I could take limit along some sequence and I could put the value f of xn. We had it as 1. But we have no information about f dash x at all except that f dash 1 is 1. I mean f dash 1 is 0. No other f dash is known. So I mean what I want is I want to know f dash at some points at least. If I know f dash at yn where yn converging to 1, then I can, yes, I mean, I can go ahead. So that is the point one should understand what is happening. So I'll just draw a picture to realize.
But in this
Huh.
type of question, counter example will work or not? Like if we choose f of x, then f of 1 is 1 and something like that.
But issue is uh, counter examples or you mean examples?
So examples.
Example. Uh, See, thing is, um, it should
Sir,
work in a sense.
like any example that satisfy all the conditions.
All the conditions. Yes. If you can catch up such an example, I mean, yes, it should work. So, do you have some example? Like, if I take fx equal to x, it doesn't satisfy this. See, yeah, I'm about to draw that picture just to look at some example. So, you see, the point is, um, see, at 1, okay, so this is suppose 1, and this is say 2. So, at 2, it is 1. Okay, it has height 1. At 1 plus 1 by 2. It again has height 1. That's the information I'm just plotting. 1 plus 1 by 3, it has height 1. 1 plus 1 by 4, it has height 1. 1 plus 1 by 5, it has same height. You get it? These are the points on the graph. But in between how it is behaving, I don't know. It's definitely not constant. So it may go up and down also in between. Right? So to imagine such a function, it again is, I mean, you have no direct formula for framing such a function, which is non-constant and going through all these points. Fine. But you know the function, means you know the behavior. We have seen such a function earlier during discussion of continuity, similar type.
Yeah, that are defined in 1 by 3, 0, 1 by 3, and 0, 2 by.
Not exactly. Yeah, not exactly. So yeah, I if I do one more step, you will realize what I'm talking about. So let me do that step. So if I'm saying x1 is, so what is x1? X1 is 2, 1 plus 1. And how much is x2? It is 1.5. Now you understand, this is a hint. You tell me what next. So f of x1 is equal to f of x2. Do you see that? Due to this. So what can I apply? Function is
Roles
different.
theorem.
Correct. Function is differentiable. So by roles, there is y1 between x1 and x2 such that f dash y1 will be 0. You understand? See, you want to travel from here to here, and so either you can go from like this or like this, or maybe more, I mean, curves you can have. So suppose I'm going like this. Okay, once. Then there is a point where derivative is 0. So that's what I'm saying. So that is my y1, right? But there is nothing great about x1 and x2. We can do this for xn and xn plus 1, in fact. Fine. So what I can write actually is you take any xn, xn plus 1, which is going to be less than xn. Then over this interval, there is yn. So there is yn lying between xn plus 1 and xn such that f dash yn is 0. Agree?
Yes, sir.
By
Yes,
Rolle's
yes,
theorem.
yes.
Uh, but on the other side, you see xn plus 1 as well as xn are converging to 1. Because xn is converging to 1, xn plus 1 will also converge to 1 only. That
Yes,
means
sir. So
yn
why
has to, correct.
convert
Yn
to
should
one by
converge to 1.
this theorem?
Sandwich, correct. So yn goes to 1. So you got a sequence yn converging to 1, and you got some information about f dash yn at those all those yns. Like this. So what I can now write is this is equal to limit yn, along yn I am taking the limit now, f dash yn minus 0 upon yn minus 0, yn minus 1. But this is going to be 0 because f dash yn is 0, actually 0. So it is numerator is 0
Yes,
like this
yes.
situation. So you get f double dash 1 also to be 0. Now, is it resembling something? Like, see, your function will behave like this. It will go up, come down, it has to go up, it has to pass through all these points. And in fact, near one, it will have to oscillate lot of times.
Sir, it is something sine 1 by something.
Sine 1 by x type.
Yes, because here
Hmm.
1 only occur when quantity 1 plus 1 by n something pi by 2
Hmm.
or n pi by 2,
Correct,
something like.
correct. So something like that kind of a behavior. Of course, it may take more jumps in between. So I'm
Yes,
just
sir.
saying it is similar to kind of behavior is similar to sine 1 by x. Yeah.
Where's the rare new
Yeah.
type question I have not seen before because in terms of transforming this limit into sequential limit, I have not seen in such intricate way of doing.
Yeah,
Very,
yeah, right, right,
very
right.
insightful question.
Yeah, yeah. Thank you, thank you.
Otherwise, Sunil has mistakenly right answer. If it would come in
Yeah,
jam,
yeah,
then
correct.
NAT time, then
Yes, yes,
he
yes.
would
One
he would
can,
done.
yeah, yeah. That is sometimes useful. Fine, fine. So this is what I just wanted to discuss with you all. So all the best. I'm happy. I'm very happy to, interact with you all.
Yes, sir.
And
We are very
yeah,
blessed to have such pleasantful
yeah,
discussion
yeah. Yes, yes. Thank you.
and very
Yeah.
very helpful, I think.
Yes, yes, yes. If audience is good, in fact, we are more encouraged.
Yes, sir. It
So
is
yeah.
something. All of the previous resource person also
Hmm. Hmm.
very engaging.
Right, right. Good. Okay, so may I stop this? I'll share this file with you all, means with the organizers. They'll share with you. Okay. So
Hello, sir.
yes, yes, Sunil.
Sir, so all the assignment that you have given to us,
Yeah.
sir, we will try first, and
Yes.
then So, so for the verification, if
Mhm,
it is
mhm.
possible, then could you provide the answer keys with
Okay, I'll try. I have not solved all the questions ideally, Sunil. So let me see how
fundamental
many.
will be okay.
I'll try to give you as much as possible to the organizers. I'll share the
Okay, sir.
answer keys. Okay.
Okay, sir. Okay, sir.
Yes, yes, yes. Okay. Yeah. So I'll stop my sharing thing.
Participants, if you have any further queries, you may ask to sir now, one by one.
Yeah. Anything else you
Sir,
want to
can
say?
you give us some suggestions for preparation?
Uh, actually, this in the sense one has to practice more and keep an eye on how much time you require to solve the problem because time constraint is also there. Try to solve previous year question papers, lot of question papers. You will get the idea that some things are always there, like what we saw, like mean value theorem. There is always going to be a question. Intermediate value theorem. Usually there is a question. So like that, some topics you can always expect the fundamental theorem of calculus. You can expect a question. So like this, some questions are unavoidable. Like those skills are to be tested to get into IIT. So that you can make out from going through the problems. So try to solve more and more problems. Okay, you should discuss with others also if you are not getting it. That is the way we learn, in fact. So
Sir,
yeah.
sir, the thing is that
Huh,
um, some of the question we can solve easily
huh,
and we get
huh.
some ideas, but
Mhm,
uh, if for some questions we are not
mhm,
getting any clue, or after getting so much clue, or like we have so much information, but when we solve
mhm.
it and get the
Ah,
different result, then yeah, the stress comes arises. Like if such types of question if come in exam, then what will happen? Something like that.
but see that scope is always there, Sunil, in such examinations. That is always going to be there. My suggestion is don't give up. And I mean, yes, if you see 100 problems, there is always going to be 101st question, which will be little tricky. So some risk factor is always there, but that I mean that we can't avoid. So the only solution to this is keep practicing more problems. Try to get try to explore more problems so that on the spot, see, ultimately, a new problem you should be the skill should get developed is how to handle a new problem, because in exam you may get a new problem. So that only we have to develop that skill, how to tackle a new question. So it will come, don't worry. Now one how many 1 month you have, right, in hand? One more month.
One and a half.
1.5, right. Okay. So all the best. Daily you have to devote some time.
Sir, any
Yeah.
particular, along with the previous year question, any particular book or any exercise from book would you like to suggest us?
Now on my topic as such, I hope I have tried to cover mm, the variety. So no, I feel first you one has to concentrate lot on previous questions.
Yes,
That should be suffice at this moment now, because textbooks, like I gave you one book that is of Korpade, Limay
yeah,
Korpade. They
yes.
have lot of nice exercises which one can look for, at least for these topics: mean value theorem, intermediate value property.
Yes,
They have
sir. There are two volume. You are talking about the single variable.
the single
Yes.
variable
Yeah.
one.
Yeah. Okay.
Yeah,
Okay.
correct,
Okay.
correct. Yes.
Thank you, sir.
Yeah. Yes. Yes.
And sir, there is a
Uh,
Taylor's theorem, application of Taylor's theorem. We are already known of, sometime we are remembering those transform expansion of some standard expansion like log, sine, cos, some
uh,
exponential.
hmm.
And this is sufficient or something extra needed to for applying Taylor's theorem without much more remembering or trickily it can be used.
See, point is you need to know the statement, Taylor's theorem statement, because that
Mm,
is what needs to be applied. And then see, standard Taylor series for standard functions is one thing that is okay, but more than that, you if given a, say, if you have some function fx,
yeah.
how do you write its Taylor series? That one should know, because that is being checked. So do you know f of x is equal to f of a plus, I mean, f dash a times x minus
Yes.
a? That expression is to be used. Like, one problem in my problem sheet requires that expression to be used.
Yes.
So, that's it. But that is a basic thing. That is enough. If you know that, you should be able to tackle the problem.
Okay, sir. Thank you.
Yeah, yeah, correct.
I hope there are no more queries left. Mandar Khasnis, sir, we are deeply grateful for your presence. We appreciate the time you took to share your knowledge with us. Thank you so
Yeah,
much for your valuable contribution to this lecture series, to your four wonderful sessions, sir. We are honored to have you with us, sir, and we look forward more such sessions with you, sir.
yeah. Thank you so much. In fact, thanks for this opportunity given to me by Wilson College. So thanks a lot. Mm.
Welcome, sir,
Yeah.
and we are always
Yes.
grateful.